Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to be going over section 6.5, Linear Inequalities. Now previously we went over a system of inequalities for our section. That was actually supposed to be 6.6, not 6.5, so please watch 6.5a before watching 6.5. It will make a world of more sense. Alright, so today we're going over linear inequalities. Well, the first thing we have to ask ourselves is, what is a linear inequality? Well, linear means line, and inequality means that there are two things that are set not equal to each other. And the way we set things that are not equal to each other is with greater than, less than, greater than or equal to, or less than or equal to signs. So inequalities use inequality signs, which is something like greater than, less than, greater than or equal to, or less than or equal to. Now, from these, we would have something like y is greater than 2x minus 4. This is what is called a linear inequality, because y being greater than 2x minus 4 turns it into a line. It's a linear equation, and if we had an equal sign instead of this greater than sign, then we would be creating just a straight solid line. But because we have a greater than sign, it means that we have a new situation going on. We have an entire region of numbers that all make this statement true. So to solve a linear inequality, you are required to graph. So to solve a linear inequality, you must graph. So pull out your rulers because it's graphing time. Now, the way we graph inequalities is the exact same way that we graph normal linear equations. So an example, I know how to graph, as soon as my computer stops going in the fritz, y is equal to 2x minus 4. Graphing that equation, super easy. Step 1, draw a set of axes. Step 2, go to negative 4, negative 1, negative 2, negative 3, negative 4, make a dot. My slope is 2, so I rise 2, run 1, rise 2, run 1, rise 2, run 1, etc., etc. And then I would draw a solid line in between each dot. So this is what we would call graphing the line y is equal to 2x minus 4. However, the example that we have is y is greater than 2x minus 4. Y greater than 2x minus 4. Now what this means is that our y value has to be bigger than the 2x and minus 4 value. So how do we show that? Well, first, we erase this line here, because we need to find out if it's going to be a solid line or a dotted line. A solid line occurs when you include the points on the line. The dotted line occurs when you do not include those points. The easiest way to remember that is to look at your inequality sign. Remember, if you have a bar, then you're solid. So looking at this, do we have a bar? Is there a bar underneath our greater than symbol? And the answer to that question is, Mr. O'Neill, no. No, we don't. So if we don't have a bar, we're not solid, which means that instead of having a solid line going through all of those points, I have a dotted line going through all of those points. This represents that I don't actually touch any of the numbers that are on the line, because if something is strictly greater than, for example, is 4 greater than 4? The answer to that question is no. 4 is equal to 4. It can't be greater than itself. So the only way for this to be true, so I'm going to write down false right here, would be if I had 4 is greater than or equal to 4, in which case this is true because they are equal, and the way that OR works in Mathland is that if either one of them is true, then the whole thing is true. That's how OR works. So when we say greater than or equal to, is 4 greater than 4? Well, no. Is 4 equal to 4? Yes. Therefore, it makes a true statement. So since we don't have a bar, we are not solid. Then we have to figure out where are we going to have our solution region. So probably we should go over what a solution region is. A solution region is an area where all ordered pairs make the statement true. So looking at this one, okay, that's fine, Chisholm. I need to find out the area or the region where all of my ordered pairs are true. So to test this, I need a test point. So to test, use a test point if it is true, then through. If false, flee. This is the same as the inequalities that we did before. In those, we did a test point usually at 0, and from the 0, if it made a true statement like 0 is less than 5, then you went through 0. If it made a false statement like 0 is greater than 5, then we would go away from it. The same thing happens here, except that what I use for my test point is usually the point 0, 0. I plug in 0, 0 to my equation and see if it makes a true statement. So plugging it in, let's see, I plug in 0 for the y, and then I plug in 0 for the x, and I get 0 is greater than negative 4. Is this true? Is being debt-free better than owing $4 million? I would say, oh yeah, it's definitely better. So if true, then through. That means we have to go through our point 0, 0. Now from that point 0, 0, I go over to my graph and I almost touch it, but I don't go through it. And this would be my solution region. All the area that's in this beautiful teal blue color is my solution region. I won't even write it down. Solution region. So it's really simple. Graph the line. From the line, use a test point. If true, then through. If false, flee. Now I know this was really complicated and confusing, so let's do it again and keep it super simple. Mr. O'Neill will do another one as if he was doing it himself. Let's say that we are given the situation y is less than or equal to 3x minus 6. Okay, first thing that I would do is I would graph the equation as if it was 3x minus 6. Y is equal to 3x minus 6. So that means I'm going to have to go down quite a ways, which means I'm probably going to have to bring this guy up a little bit because I'm out of room down there. So I'm going to put my x-axis up here. Let's see, I go down negative 6. So 1, 2, 3, 4, 5, 6, make a dot. And then my slope is 3, so I rise 3, run 1. Rise, wait, 1, 2, that was only 2. Oops. Rise 3, 1, 2, 3, run 1. 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 Okay, so I rise 3 and run 1. Then I have to decide, do I make a solid line or a dotted line? I have a bar, I'm solid. If you've ever been hit by a bar, you know those things are solid. So, if you have a bar and you get hit by it, you're solid. Okay, so I have a solid line going in those directions. Now I need a test point. Again, I'm going to use the test point 0, 0. I will use 0, 0 for every test point possible unless the line passes through the origin, unless the line passes through 0, 0. Then I'll probably pick like 1, 1 or -1, -1 or something equally easy. I want my test point to be as easy as possible. So plugging in 0, 0, I get 3 is less than or equal to 3 times 0 minus 6. So I get 0 is less than or equal to -6. This is false. 0 is bigger than -6. This is saying 0 is smaller than -6, so I know I don't go through the origin. So normally I'd want to go through here, but I can't. I got to go the other side. So the other side would be in this area. So I highlight in this area. Now I know some of you are like, Mr. O'Neill, you know, I've learned some other ways of doing this. I've learned that if it points to the left, then I'm above or below it, and if it points to the right, I'm above it. Well, that works most of the time. It doesn't work if you have something like 2x minus 4 is less than or equal to y. Using the arrow telling you which way you're supposed to go only works if you have it in the correct format to begin with. I don't always see things in the correct format all the time, mainly because I'm a teacher and I'm used to kids not doing it the right way. But on the other hand, if you understand it, you will never have to worry about, is it in the correct format? Am I doing something wrong? Could I be doing something different? If you always use a test point, you never have to memorize which way anything goes. All you have to remember is if it's true, then I'm obviously going through that point. If it's false, then I'm obviously not going through that point. Super easy. Much easier than trying to remember if it points to the left, I go below, or to the right, or to the left of it. It just, no. Keep it simple. Use a test point. If true, then through. If false, flee. Alright, and that is it for today, which means that it's time for your before you go work, or your bug work. Now your bug work will look very familiar, probably because if you watched the other video, you did most of these already. So bug work is going to be section 6.5, hashtags, math is the shiznit for Rizzle my nizzle. Let's see, 1 through 11 odd. And then 13, 17, 19, 21, 23, 25, 29, 31, 33, 37, and 39. Alright, a lot of these should be familiar because you've already done a lot of them if you did the previous video. If not, then after the next video, those should be super easy too. Alright, thank you very much, good luck, and have fun.